This is Unit 1, Video 2, and here we'll talk about some numbers associated with atoms and elements. First number we'll introduce is the atomic number, which is a logical thing to introduce because we're talking about atoms. It's actually symbolized with the big letter Z. Scientists have decided to use big Z, and no connection to yours truly. But this refers to the number of protons in the nucleus of the atom. And it actually identifies the element. So think of this as the number that tells you what kind of atom you are dealing with, the atomic number. So every element on the periodic table has a number above it, and it's a whole number. It's like 5 or 8 or 83, and this is the atomic number. And it tells you how many protons, really important. So for example, lithium has 3 protons because it has atomic number 3. Copper is element number 29, the 29th element on the periodic table, and it has 29 protons. So this is really simple, really basic idea. Make sure you know what the atomic number is. Now here is the periodic table for your visual pleasure, but every element is arranged by its atomic number. So in order to do this, scientists actually had to verify how many protons in the nucleus of every element. So every element, once we've verified how many protons, then we were able to arrange the periodic table properly, and that's how the periodic table is arranged. And there's a key here for you to see what that means. We'll discover what the rest of these numbers mean eventually, and you'll have all the knowledge about the periodic table you need. Now here it says all atoms have the same number of electrons as they have protons. So electrons and protons will be equal for atoms, and the reason for this is because atoms are neutral. So an atom technically is neutral. The positives and negatives are balanced. Remember, the positives are in the nucleus, the negatives are on the outside. In this case, you have 4 positives, 4 negatives. This is the element beryllium, and it has no charge. Now, when you lose, atoms can lose or gain electrons. They obviously can attain a charge, but we will no longer call them atoms. We will call them things like ions, as we'll see. So ions will have a charge, but the atoms are, by definition, neutral. So, quick question, how many electrons and protons does an atom of silver have? Really easy to solve. Find silver, Ag, on the periodic table. Some of these elements use their Greek names. Here it is. Here's silver. And simply find the atomic number, which is 47, which means silver has 47 protons. And because it's an atom, it also has 47 electrons. Sometimes we'll say protons with a little positive, electrons with a little negative to designate their charge. So really simple. Take a moment to try problem 2 and keep going. Now let's define an ion. An ion is an atom that has lost or gained electrons, which means it has attained a charge. So sodium, for example, very commonly will lose 1 electron. That's the most common thing for sodium to do, and this represents a tiny little electron around sodium. And when it loses the electron, it becomes positive. Now the reason it becomes positive is because electrons, remember, themselves are negative. So if you take away a negative, you become a positive. And the way to think of it is if you had 3 positives and 3 negatives, and if you remove, so the overall charge here is 0. They match each other up. But if you remove one of the negatives, then you have more positives. In fact, now you have a charge, an overall charge of plus 1. And what we do is we write the charge in the upper right of the element symbol. So the charge is always written up here. Now sometimes you can include the 1, and sometimes you don't have to include the 1. You can simply do it like this. Everyone understands that if you just put a plus, it means a plus 1. Now if an atom loses electrons, it becomes positive, and if an atom gains electrons, it becomes negative. So again, this is kind of what I just spoke about. Since electrons are negative, if you gain an electron, that's like adding another negative, and so the overall charge will be negative. Oxygen's most common way of reacting is by gaining 2 electrons, so it ends up having a -2 charge. Sodium's most common way of reacting is by losing an electron, creating a +1 charge. These are the most common charges of these 2 elements. As you'll see, elements have a very common charge, and we'll talk about that a little later. So, quick example, or 2. Write an ion of nitrogen which has gained 3 electrons. So first of all, we'll have to find nitrogen on the periodic table. And if you find nitrogen, you'll see nitrogen is element number 7. which means nitrogen begins with 7 protons and 7 electrons. Now, if it's gained 3 electrons, that means it now has 10 electrons. Now, it used to have 7, and now it has 10, so it has 3 more. And because electrons are negative, since nitrogen has 3 more electrons, we'll put -3 in the upper right-hand corner. And that's how you write an ion of nitrogen containing 3 electrons. You simply put the symbol down, and then put the charge resulting from the gain or loss of electron. All right, how about write an ion that has 11 protons and 10 electrons? So we've actually just done this, and 11 protons belongs to the element sodium. If you take a look at the periodic table, sodium actually has 11 protons, and since it has 10 electrons, it has lost an electron. So we'll put sodium out. Since it's lost an electron, you have now a +1 charge. You remove a negative, you reveal the positive of the nucleus, so that's a +1 charge. Okay, and then how many electrons does this ion have? Here is an ion of titanium +4. If you take a look at the periodic table, find titanium, you'll find that titanium is element number 22 in the periodic table. Now, since it's element number 22, it originally has 22 protons, so that's really easy. 22 protons, if you think of protons are positive, that's because the atomic number is 22. Now the electrons, does it have, now it has a +4 charge, which gives us a clue. Does this mean it has 4 more electrons or 4 less electrons? Well, because the protons are winning, if you think of it that way, we have 4 more protons than we have electrons, which means we have 4 less electrons, which means we have 18 electrons in this ion. So hopefully that made sense. Go ahead and try one on your own. Take a moment. Okay, and then let's talk about isotopes. Now, isotopes are, the idea of ions relates to electrons, and the idea of isotopes relates to neutrons, as you'll see. Isotopes are atoms of the same element that have a different number of neutrons, so you can actually switch neutrons. In fact, you can have 2 different atoms within the same element, and they'll be different by the number of neutrons they have. So that postulate, one of the postulates of Dalton that said all atoms are exactly the same, is actually not true, because within atoms you can have isotopes. So here it says they have a different mass. Because neutrons have a mass, a relative mass, you have to account for that, and so isotopes are going to weigh different. Electrons, remember, do not have any mass, so electrons, like an ion, has the same mass as an atom, whereas an isotope will have different masses. And here an electron is shown as really tiny, and its mass is insignificant. So to understand isotopes a little better, here are 3 isotopes of element number 1, the simplest element of all, hydrogen. Now here we have hydrogen, because we know it's hydrogen because it has only 1 proton. Remember, if you have 1 proton, you're element number 1, which means you're hydrogen. Now, and it also has 1 electron, because an atom has to have these match. Now here is also an atom of hydrogen. This is also hydrogen. This is called hydrogen 2, and also called deuterium. Sometimes they have a special name for this, deuterium. And what happens here, it's hydrogen because it still has 1 proton, 1 electron. However, it has a neutron in the nucleus. So now it's an isotope. It's still hydrogen, but it's an isotope. And here we have the dangerous isotope tritium. This is actually a radioactive isotope that's used in forming or creating nuclear bombs. And it's still hydrogen because it got 1 proton, 1 electron, but now it has 2 neutrons. Now, the total mass right here, as you'll see, will be 3. And this is called hydrogen 3, or tritium for short. This one's really unstable, and the reason it's unstable is because it has too many neutrons for the protons. Usually neutrons and protons like to be evened out. So this is unstable and radioactive, so don't come near any tritium. This introduces to us the concept of the mass number. Now the mass number is the total number of protons and neutrons in the nucleus, and it identifies what's called the isotope. Remember, because neutrons and protons and neutrons have mass, we can put them together and talk about the mass number. Usually letter A is designated for the mass number. Remember, letter Z was designated for the atomic number. And the way you write this is you write the sodium atom, essentially. Down below goes how many protons it has, because it's element number 11, up above to the left goes how many total protons plus neutrons it has. So it has 23 total protons plus neutrons. And from this you can find out how many neutrons it has. Because 11 of these are protons, the rest of them, which is 12, are neutrons. So actually you have 12 neutrons in this case, 12 neutrons in the sodium isotope. So this sometimes is written without the bottom number. Notice we can just write it like this, just with the 23. The reason why we don't write it with this, because everyone should know, if you have a periodic table handy, only sodium can have 11 protons. No other element can have 11. So this is kind of redundant. You don't really have to mention this. So let's do some different ways of writing isotopes. There's actually two ways of writing isotopes. There's what's called the hyphen notation, and a hyphen is a fancy word for dash. And so what you do is, if you want to write hydrogen 3, you write out the full name hydrogen with a hyphen and a 3, hydrogen 3. You'll also see it written just H3. This is less common, but usually we write out the whole word or the whole element name. If you want to just use a symbol, usually you use what's called nuclear symbol notation, and that's what we just saw up above. And this is where you put the atomic number down below, 1 proton, and then the mass number up above. And again, this is protons plus neutrons, which means this hydrogen isotope has 2 neutrons. Let's go ahead and do some examples. 4a says how many neutrons in chlorine 37. So take a look at chlorine. Clue number 1 always is the periodic table. Find chlorine, which is element number 17, which automatically has 17 protons. Chlorine has 17 protons. Now this here, remember, is the mass number, and the mass of an atom is calculated from its protons and its neutrons. Those are the two particles that contain mass. So we have to subtract away 17, and what's left will be the neutrons. So the neutrons, 37 minus 17 is 20. We have 20 neutrons in this element. Okay, and then how about write the isotope that has 35 protons and 40 neutrons. So first of all, we have to find out which element is this. Now every element is identified by their number of protons. So look at the periodic table and find the element with the number 35 above it, which will be the element bromine. The element bromine has 35 protons. So we can actually write bromine and then a hyphen. And we want to write, now we don't write 35 in here. This, remember, is the mass number. It's protons plus neutrons. So we'd add the two together. So 40 plus 35, so you get 75. This is actually bromine 75. Another way of writing it is nuclear symbol notation. So you can put bromine and 75 in the upper left-hand corner. You can also put 35 down here if you'd like. It's not required, but that is a way to write an isotope that has 35 protons and 40 neutrons. So go ahead and try this on your own, and pause the video and make sure you understand how to write isotopes and ions.